continue on with the second part of the lesson here. So the next 2 pages are pretty simple. If you haven't tried them already, I want you to give them a try. Question 3 just asks you to determine if they're mutually exclusive or not. So is there overlap between the 2 sets? Question 4 and question 5 here on the next page just involve Venn diagrams and then using that to help us determine probability of possibly mutually exclusive events or not. Okay, I'm going to give you guys a little bit of time, so you want to pause the video here and try them out. All right, so hopefully you paused and tried. So let's go through. So let's see if this first one here is mutually exclusive or not. We've got Leonard, he rolls 2 4-sided dice. I'm going to draw out my sample space here. He wants to move if the product, so that's a times, is even or greater than 6. Okay, so we have 1, 2, 3, 4. 2, 3, 4. So my sample space is going to look like this. There's 16 numbers in it. So 1 times 1 is 1. 1 times 2 is 2, 3, and 4. And then 2, 3, and 4. And then we got 2 times 2 is 4. We have 9 and 16. I could just do those ones because it's squares. 2 times 3 is 6. 2 times 4 is 8. 6 and 8 as well. And then 3 times 4 is 12. And 3 times 4 is 12. So that's what that one looks like. That's pretty cool. It's pretty symmetrical. Now what we want to know, where are the even numbers? So let's go through the even numbers. We got 2, 4, 6, 8, 12, and 16. Oh, we got some 4s on the outside here too. All right. So those are the even numbers there. Cool. And then I also want to know which numbers are greater than 6. So I can just highlight everything that's greater than 6 here. And you can see that, oh, there's also even, I forgot about him. You can see that there are some overlaps. These areas here turned green. So these are not mutually exclusive, since 8, 12, and 16 are even and greater than 6. Okay, so just give you a little reasoning why. All right, Howard has 1 standard 6-sided dice and 1 standard 4-sided dice. He can move if it's a sum, if it's even or 7. I already know that these are going to be mutually exclusive since, oops, I probably forgot the whole word exclusive. Maybe I should put those words in there. Since 7 is not even. So there's going to be no overlap here between those 2 events. Okay. Sheldon rolls 2 standard dice here. 1 red, 1 blue. He divides the number on the red by the number on the blue. He can move the quotient either a whole number, okay, or a terminating decimal less than 1. Okay. So a terminating decimal less than 1 is not a whole number, right? A whole number, if you remember correctly, a whole number is a number of 0, 1, 2, 3, 4, 5, 6 with no decimals, and a terminating decimal less than 1 will never be a whole number. So there's no intersection between these 2 spots. They are totally separate from each other. Now, 2 is a terminating decimal, but it's not less than 1. So these are non-mutually, oh, sorry, these are mutually exclusive, sorry. And I can write down here, since a number less than 1 is not whole. Okay, so they're not gonna cross over each other. Now Penny rolls 2 4-sided dice. She can only move if the difference between them is even or less than 3. Okay, so let's look at our sample space here. It's got another four-sided dice, so 1, 2, 3, 4. 1, 2, 3, 4. Okay, and we want to know the difference, so we're going to subtract these. So we've got 0, 0, 0 down here, like 4 minus 4, 3 minus 3, 2 minus 2, etc. 2 minus 1, 1 minus 2. We're going to just leave them all positives here. 3 minus 1 is 2, 4 minus 1 is 3. 3 minus 2 is 1, 4 minus 2 is 2. Okay, 4 minus 3 is 1, okay. 3 minus 1 is 2, 4 minus 1 is 3. 3 minus 2 is 1. 4 minus 2 is 2. This last one's 1. Okay, so let's go through and just highlight which ones are even. Okay, 0 is technically an even number. Any number that can be divided by 2 is even, and 0 is the most even of all numbers because 0 divided by 2 is 0. And then divide by 0, 2 again, divide by 2 again, and keep on going. So 0 is technically an even number. It follows the pattern too. It's between two odd numbers, so it must be even. 2 is even, so there's those. And now we're just going to say which ones are less than 3. Which ones are less than 3? 2. Oh, I was going to use a different color there, not green. Oh. Okay, let's use the blue one here. I like that. Okay, so let's use our blue. So less than 3 is 2, 1, 0, 1, 2. We highlighted quite a bit there, and there's a lot of green in there where they overlapped each other. So they are not or non-mutually exclusive events. Okay, lots of overlap. Okay, so let's read this next one. Christina here has a probability that she'll study on Sunday as 0.5. The probability that she'll practice the guitar on Sunday is 0.4. The probability that she'll at least do one of these things on Sunday, I'm assuming, is 0.7. What's the probability that she will do both of them? Okay, so I'm going to look at this as a Venn diagram question. So there's lots of different ways to try to approach this question, but a Venn diagram looks like the easiest way. And what I know, she's going to study and she's going to play guitar. So I got these two pieces. Okay, and I know that the union between these two, so that I have the probability of guitar and studying, is 0.7. Okay, now I also know that there's a formula for this. Probability of her playing guitar plus the probability of her studying. Now, this would be if they're mutually exclusive. So I'm going to assume in this situation, because we're looking for probability, this is what we're looking for here, is that there is a little bit of overlap. So I'm going to have to subtract out that overlap. And that's what I'm actually looking for. We're looking for this overlap. How much is that? Okay. So they gave us a bunch of numbers here. And we could do this otherwise too. Like we know that these two circles have to add up to 0.7. That's all these three pieces here. I know this big circle here is 0.5. That's a study one. I know the guitar one is 0.4, so that's 0.9 altogether. So that's 0.9. Like the two circles are 0.9, so 0.5 plus 0.4, that's 0.9. And technically the two circles should add up. I'm going to subtract out that 0.7 and get 0.2. So that's probably the probability of them being together. Now I just want to double check that with this formula and see if it actually works. So that side here, this side here, the union of the two sides, which is the everything inside the two circles, has to be 0.7. The probability of the guitar is 0.4. The probability of studying is 0.5. and we're looking for this piece here. Oh, I don't know why I made that an A. That should be just a weird looking N. Okay, I'll fix that. Okay, so I'm just going to rearrange it. Actually, I'm going to add these two numbers first. Get 0.9, very similar to what we got over here. We got a 0.9 as well. Then 0.9 over here. And then I have this. I'm going to rearrange this a little bit. I'm going to subtract over the 0.9, get negative 0.2. Then I have negative P, the intersection between P and S there, or G and S, sorry. They're both negative, so I can just change them both to positive. And we get the exact same solution that we had over there. Why did I make an A? It's the habit of making an A out of this weird looking N. There we go. So both ways kind of give us the same solution. One way is the formula, one way is just by using the Venn diagrams that we used before. Okay. The next one here, Muhammad is, what's Muhammad doing? He's going to go swimming to the swimming pool on Tuesday. What we know is that it's going to be 75% or 0.75. That's the probability. Probability he will buy groceries on Tuesday is 0.5, and the probability he will do neither is 0.1. Which of these Venn diagrams is the proper Venn diagram? Okay, so the first thing I want to know is what is my universal set? So the number in my universal set is 1.0. The reason behind that, that's 100%. Everything that happens on Tuesday is in this 100%. Now, the union between S and G, swimming and groceries, is everything in these two circles, right? What do they happen to be? Now, what that is just going to be 1 minus 0.1. So 0.9, right? There's a 0.9 probability he will do something. Right? Will do something. Right? Don't know what they're going to do, but there's at least a 90% chance this person will do something here. And what we know is if I add my two circles together, 0.75 plus 0.5, these are my two circles, not including that overlap. This includes the overlap twice, right? I get 0.25, 1.25, sorry, which is a little too big because there's a 90% chance he'll do something. So what I'm going to do is I'm going to subtract the 0.9, and I'll get 0.35 will do both. So there's going to be a 0.35 overlap. So what I'm going to do right now is I'm just going to cross things off. I know there's an overlap. So I'm going to cross off D, doesn't have an overlap. A, they calculated the overlap incorrectly. So these two look pretty good. They both have the proper neither on the outside, so that looks pretty good there. They both have the proper overlap here. But one of the circles has a 0.15 and one circle has a 0.5. So the swimming circle, what we remember about that, the swimming circle should add up to 0.75, 0.4, 0.35, yeah. So that works out. And the guitar circle should add up to 0.5. No, what does it add up to? Yeah, 0.5. Okay. So 0.35 plus 0.15, yeah. That'll add up to this number up here. This one here doesn't add up. That's too much. That's like 85% chance of doing a guitar. Now, we can also do this by using the formula, right? So I can say that SUG, which we know is 0.9, when we decided that from the top up here, that it was 0.9, is equal to the probability of S happening plus the probability of G happening minus the probability of S and G happening at the same time, because we have to get rid of that overlap out of these two circles. So I'm going to just write out my formula. What we have, probably S happening is 0.5, or groceries, one of the two, can't remember. The other one's 0.75. I'm going to minus S intersect G here. I'm going to rearrange this formula. I'm just going to subtract these two pieces over to the other side. And I'm going to get 0.35 is equal to SG. Exactly what we had before. You can see that this and this are both the exact same. So when we did our Venn diagrams, we did what's on the top there. But now we have what we call it. We have a formula now that could actually help us solve these as well. They end up being the same. What are the odds? In favor, spelled the American way for some reason, of Muhammad doing at least one of these activities on Tuesday. So do at least one means that's just pretty much everything. So he's going to at least do something 90% of the time, and then he's not going to do something the other 10% of the time. I'm going to reduce this or modify it so we're using whole numbers. So it's a 9 to 1 odds in favor of him doing something. There we go. Okay, so that finishes off that video. So what I want you to do is to, well, continue on, work through that worksheet that's also attached to this lesson, and I will see you in the next one. Bye.